are you doing? Are we still with me? Come on. That's the spirit. Love the energy. Thank you for your warm welcome. Platform engineering and building platforms, it's starting to become more and more popular. Have you ever wondered why is that? And more importantly, have you ever wondered, like, what's the journey that you need to take should you want to go that direction? My name is Adrian Bere. I work as a solution architect for Amazon Web Services. And today, I'm going to share my experience while working with customers, but also from my previous experience, because I used to spend like the last 10 years before joining AWS building these sort of platforms which go around the Kubernetes ecosystem. And I'll start by showing what are some of the benefits for implementing such platforms, but also, most importantly, I'll showcase some of the challenges. I'll try to give you a bit of a perspective on some of the best practices or pitfalls that you want to avoid. I'll also share some tooling, some open source tooling that are available there in the CNCF community you might find interesting and you might be wanting using in your projects. But before jumping in, I have a question for you. How many of you are working as a DevOps, SRE, or leading a platform? Raise your hands. A few. Okay. How many of you are developers? Many more. Okay, so developers, this is also a talk for you. You'll notice why. So if you're someone building a platform, most likely your internal customers are developers, are teams of developers who are building some sort of application. It could be one application, it could be a catalog of different apps, back-end, front-end, you name it. And those applications need to run on some sort of infrastructure. And that infrastructure is quite it has a lot of variety. It could be compute, it can be databases, it could be storage, and so on. So your job as someone who's developing this platform is to accommodate all of those needs and build some sort of abstractions. And the first thing that you need to think about when starting this journey is who's going to manage that whole infrastructure? Who's going to own that? And there are two main parts in this spectrum, as I like to call it. On one hand, you can go with this model where you can have everything decentralized. What does that model mean is that the application developers are in charge for running the infrastructure and deploying the infrastructure, troubleshooting, and so on. So they do the whole thing. It's that you own it, you build it type of model. Now, on the other side of the spectrum, you have the centralized model, where developers don't need to think about infrastructure and how to deal with that and how to set up like cloud services and things like that. They have someone who builds that for them or creates a platform whose job is to provide some sort of a self-service API or something like that. Well, along the lines, you're going to end up somewhere between this. I like to think about abstractions in the following manner. What you see on the screen, there's two pictures. In one picture, you have the parts of an engine. On the other side, you have a full, complete engine. Now, there are many people in the world that can take parts and build an engine out of those parts. But there are also a lot more people who just want to take the engine, put it in the car, run the key, turn it on, and just drive away. The same principle applies in a way in organizations. So I'm sure many of you in the room, and I saw your hands up, can take bits and pieces of infrastructure and create applications out of it, but there are also a lot more who don't need to think about that. So that's one thing that you need to keep in mind when building abstractions. Now, there is a quote that I really like which talks about platform engineering. Don't bother reading it. It's not super important. I just want you to focus on two things. First, self-service. When you think about the platform as a self-service, there's a lot of implications. When you're creating something that you want others to use, you need to think about documentation. You need to think about tooling. You need to think about support and all of these things. So building a platform is not just about doing abstractions of infrastructure. It's more than that. The second part is compelling internal product. This is key for me. Treating the platform as a product, it creates a mindset that allows your customers, which are the developers you see next to you, to start using that. Now, building an internal platform is a challenge. It's an investment that you need to do as an organization. It's not something trivial, and it comes with a cost of investment and so on. So why do companies even start doing platform engineering? Well, there are some benefits that you get along the line. First is velocity. So because you already have some sort of a component, some infrastructure components that are already deployed, and you can reuse resources and components, your developers can start with an idea to production very quickly. They can move faster. This is one thing. Well, moving fast, you could think that maybe you can, I don't know, treat security with less of an importance. Well, that's not the case, because when you build an internal platform, you also get governance and security. Why? Well, because you have the chance to set up guardrails. You have the chance to set up security best practices and so on, and bake it into the platform. The third thing is efficiency. So because you're able to use the resources more efficiently, the compute resources, you get a cost reduction, you get also a reduction in total cost of ownership, which means people in your team have to work less because you reuse components and so on. Super nice, super good benefits, but that's not it. There's also challenges. So let's take a look at some of the implementation patterns and what are some of the things that you need to think when starting this journey. First of all, you need to align to this spectrum of standard and autonomy. When you're getting into this journey, you'll most likely have this problem. Developers want to have freedom. They want to use all of the resources. They want to use all of the tools. They want to move fast. That's understanding. Platform engineers and platform builders, they want to set standards. They want to gain those benefits, velocity, governance, and so on. So there's always a battle. Have you ever seen this in your company? All right, I hope so. So you have some experience. So you have to decide, like, what's the sweet spot. I wish I could tell you that there is a silver bullet that, hey, you should do this or that. That's not the case. It depends on an organization, and you need to identify what's the the good spot between being fast and also keeping security in mind. There are also other challenges when embarking into a platform engineering strategy. First, ownership. Like, how do you define where you draw the line? What type of level of abstraction should you have? Should you give your customers, meaning your developers, access to a cluster or access to just some components in the Kubernetes cluster, maybe using namespaces and so on? What's your level of abstractization? There's also a problem with adoption. And I've seen this and I've done this mistake before. I was working in a team, we created this awesome platform, it was perfect, we spent like a lot of time investing in that. You would just put your code, it runs, it's perfect. Guess what? Nobody was using it. Why? Well, because we didn't involve the developers, we didn't do proper documentation, we didn't understand their needs, and so on. So you need to start working with developers. There's also another component, and this is also from my experience. You create this platform, you tell your front-end developer, hey, just give me your app, I run it into a pipeline, it just works, you don't have to think about anything, but once something goes wrong and the application breaks, it's your fault. Go and troubleshoot. And then all of a sudden you need to go and put like kubectl logs and things like that. You need to create a way to troubleshoot and monitor quick and create a good experience out of it. And also, you'll have to define some patterns. You need to understand which type of service do you want to allow to your customers. Is it template as a service? Is an account as a service? It's cluster as a service? Namespace as a service? How many of you have used this? Cluster as a service? 1, 2. Namespace as a service? Yeah. So there are a lot of variables. There is no one size fits all. You cannot, even you cannot agree between you. So the key point is there is no one size fits approach. Okay, but what can I do then? So if there is no solution, how can I do it? Well, there are some things, and the most important thing that I think it's crucial to think about while developing a platform is changing your mindset towards building a product. Is this type of working backwards from your developer experience. And also from the business. At the end of the day, you're working for a company who needs to do some business. So you need to understand what are your processes, what are your ways of doing business, what type of architectures you need to support, what type of data, and what are the dependencies between that data, and so on. How are you going to do software automation? And also importantly, what's the developer experience? And then, obviously, you can end up using some tools, some technologies, set up some configs, and so on. But the product mindset and working backwards, it's super important. Now let's do a bit of an exercise and see how that could work. So we have the developers, and we need to start this project, and we want to build this internal platform. First thing that we need to do is to have a repository where to store things. And the most popular solution out there is Git, using Git. Okay, so now we want to create some microservices, and we want to use containers, and we want to orchestrate that with some type of solution. Well, we can use something like Kubernetes. We choose this solution because that's what most of our team members have experience on, and we realize that this is something that it's fit for us. Okay, now we have the code in GIP. We want a way to automate some of the software development, and we found out this new type of doing automation and continuous integration, GitOps. And we want to use Git as a source of truth, and everything that is put in that Git gets synchronized automatically into Kubernetes. And you can start using Argo for that. Well, okay, that's good, but then from experience, especially when you're working in a cloud environment, you also need to provision more stuff. You need to create a database, you need to create an S3 bucket, and so on. How you can do that? Well, you can start using infrastructure as code. You can start using Terraform or CloudFormation or whatever, but you realize that your developers don't want to learn yet another tool, yet another technology. Can you use Kubernetes and manifest files to provision infrastructure and let them do the thing just by using YAMLs? Well, you can do that by using a CNCF tool named Crossplane. Crossplane creates controllers in the Kubernetes cluster, which allows you to provision different resources from the YAML file. So now the Git repository is the source of truth for both code and infrastructure, configs, and so on. Okay, this is nice. How can we improve the developer experience? Because now we have a lot of microservices scattered around, a lot of siloed application. Nobody knows how to read the documentation. We don't have any standards. We don't have a single pane of glass to understand what are our software catalog. So you can use something like Backstage, which is also an open source project developed by the folks at Spotify, which offers you an interface where you can specify all the relationships that an application has, all the documentation in just one interface, improving the customer experience. And at the end, you could end up with something like this. This is an infrastructure architecture that I've seen used with a bunch of customers, and basically it's exactly what I told you. The developers put a code in Git, then it gets pushed into Argo. Argo takes those changes and runs those changes against OPA, Open Policy Agent, which is also an open source tool which allows you to enforce policies, governance and things like that. Once that is checked and the developer has the right access to enable and create resources in the cloud, it uses the API to basically create an S3 bucket and all of the other resources that you would use normally on a project. You can also create different clusters, create clusters for an entire team, and so on. And then once that application it's completed, you can put it in Backstage and have a single pane of glass of the whole microservices that you're running inside the company. Now, this is one way of doing this. This might or may not work for your company. I saw some of you taking pictures, which is good. It's a good starting, but that doesn't mean that this is the only source of truth. You need to actually work backwards from your needs and from your own organizational processes. Now, let's talk about some of the things that I think they're important to keep in mind. First of all, build with your customers. Work backwards. I think this is the crucial key factor for having success and for driving adoptions. You need stakeholders. You need people to actually use your platform. Otherwise, it's something that you've built and nobody wants it, right? It doesn't serve any purpose. You need to work backwards. Another thing, there is no such thing as perfect platform. Don't get stuck in just planning and this analyzing paralysis, like trying to build a perfect platform, trying to use the perfect tooling, trying to put things ahead. Remember, product mindset. It's a product, so products have the tendency to evolve. Start with something meaningful. Start by identifying an actual need and implement that if that's the case, and iterate. Get feedback, improve it, and so on. Provide escape hatches. Sometimes when, and I've seen this quite a lot, people start creating these standards, these super nice platforms, but they forget that the truth that we have today might not apply tomorrow. So the state that we have today might not mean anything tomorrow. So you need to be a bit flexible in your design. Provide some ways of doing non-standard workloads. Adjust to that. Be okay with that. Don't be super rigid. There is no size fits all. And this is also very important. Try to understand that not all the workloads are the same. You might need to accommodate maybe large language model creation. You might be needing to support event-driven architecture. So there are a lot of workloads that you need to take into account. So there is no just one workload, we're going to build this platform, is going to work for everything. Also, documentation and education is key. You need to document things and also provide support for your internal customers, for your developers. I've seen cases when also platform teams are doing happy hours, enablement things, trainings, office hours, just to help drive the adoption. This is crucial if you want something to be actually used. And if I made you a bit excited about the tooling and the services that are popular in this world, I also put up a slide where you can find many other open source tools that I've seen getting more traction in the open source community and CNCF. There are things that we didn't had a chance to touch in this session, like observability, another very important part about building platforms. You have Prometheus and FluentD being super popular. There's also cost management, so KubeCost and Carpenter, which allows you to basically do a bit of optimization on how you allocate resources in a Kubernetes cluster, can help drive costs down, and also compliance and so on. There's also an initiative, an open source community initiative, which you can find on the link that it's stated on the slide, which it's a community of different enterprises who are doing internal platforms, and the whole goal of this initiative is to create a unified way of using these tools. Sometimes having too much of a tooling can get you into that analysis paralysis type of situation. So I think this is also an initiative that you might find interesting when starting this journey. Key point here is that there is no silver bullet, that's for sure. While there are things that you can do, and I've showed some of them, like doing documentation, making sure that you're flexible with your architecture, and I even provided you a glimpse to how an actual reference architecture could look in the cloud. You need to really identify your own needs. You see on the slide my contacts. You can reach out on LinkedIn. There is also a QR code. You can send feedback. I would love actually to hear from you. What's your own experience while trying to build such platforms? And obviously, I'll be around here. You can reach out. We can talk in person. And thank you so much.
Thank you for this splendid presentation, Adrian, sorry, very close. So while we're waiting questions from the audience, I do have to ask you, what will you respond to Josip from the first presentation?
This is a good question. I'm not sure I'm in the right position to answer about his project. I think they did their decision. I'm not sure that I'm really, I have all the information to speak about the project. What I can tell you that my understanding it was that cost were some of the key challenges, and I also had some conversation with other speakers. This is something that I actually talk a lot about. Like costs should be, and especially when dealing with cloud, should be a non-functional requirement. You should treat cost as you treat with everything that you're doing while building an application. When you build an application, you think about architecture, you think about testing, you think about performance testing, you think about a lot of stuff. You should include, in my opinion, cost as well from the beginning, so you can monitor that and so on.
Okay, good. And we have a question from the audience.
Sure.
Any advice how to better implement configuration management for apps and multiple environments?
Yeah, so configuration management, it's quite a tricky one. This is probably one of the other pain points that I hear from customers. Often you get this different teams trying to do a lot of configuration in one manner, but then you have requirements for other teams that want to do, I don't know, some different things, right? So you have this battle of I want to support everything, every workload, every configuration, everything. Well, there's hard to find an exact tool which will help everything and anything, right? So it's super hard to say, okay, this is like one thing that you can do and will solve everything. So.
Thank you. And one more question from the audience: how to use AWS or clouds and not bankrupt the company?
Well, I kind of talked about this. Like, use cost as a non-functional requirement and treat it like that. So, and also talk with us as solution architects. This is one of the things that I do more often with customers. I go and talk about costs and look at their infrastructure and architecture and try to optimize that. Sometimes having an extra perspective on things helps a lot, because I've seen a lot of cases where, I don't know, maybe because at the beginning the people starting developing the application didn't have the necessary skills, or maybe didn't have the time to actually look at the costs and look at the whole infrastructure. Someone like me coming in and having a conversation and understanding what are their achievements and what they are trying to build can lead into optimization and cost reduction and so on. So changing sometimes the architecture, changing the strategy, maybe using other things. Cloud is not like the silver bullet. As platform engineering, it's not, by all means. I mean, not everybody should use platform engineering. This is not the point.